Okay. You got the two batteries. This one's just a 6.6 volt. This is three 6.6 volts wired in series. So plus to minus, and then the minus and plus come together and come out. So that creates a total of 19.6 volts. The 19.6 volts will power the 18 volt DC motors, the drill motors that I'm going to be buying. The 6.6 volts will power the normal servos, the hobby level servos. Now, we'll have a motherboard of the main PC, the USB, which will run to the Arduino. The 6.6 volt red and black, positive, minus, ground voltage, will run to the ground and positive of the servo, and then you also have to share a ground with the ground of the Arduino. Now the digital PWM communication will happen with one of the digital output pins of the Arduino, and that goes to the servo. Boom, done. Now, for the DC motor control, you need a digital output pin running to a 2.2K or 1K resistor. 1K ohms could be fine, which runs to a high voltage, high amp MOSFET. I bought 150 amp, 60 volt MOSFETs. MOSFET basically is a type of transistor. It's basically an on-off switch. It's solid state. There's no moving parts. When you send an electrical current to it, it either it turns it on instead of off. By default, it's off, I guess. So you got the ground coming from your 19.6 volt power supply, and this controls whether or not you have ground. If you take away the ground, the circuit's broken, the motor doesn't work. Here's the positive voltage red wire. That one just runs straight to the motor. Now, these four are all on Y's, and you see this Y goes to negative and this Y goes to positive. This one goes to negative, this one goes to positive. So by default, this one will be on, connected, this one will be on, and that will cause it to turn clockwise or whatever. Now, when you want to switch directions of the motor, this one turns off and this one turns on. This one turns off and this one turns on. So that way this positive side is now running to the former negative, and this negative side, it's negative, is now running down this way to the former positive. So that reverses the flow of electricity, which turns the motor in reverse. Now these are just diodes. This one goes from the negative to the positive, preventing electrons from flowing from right to left. This little band on the end of the diode indicates the direction of the diode. In this case, it's pointing to the right, and you can see that here. If the band's on this side, the electrons flow this way, but they cannot flow this way. Okay, now, the same thing with this diode. It won't electrons flow that way. So you needed the diode for the active circuit. In this case, when this is the active circuit, the diode's covering that one. When this is the active circuit, the diode's covering that one. So you need separate diodes for the two different directions. Now this is a 0.1 UF ceramic capacitor, which will be right here, and that prevents electric noise that's created by this, where sparks and stuff are produced by the motor, and it prevents that from causing bad feedback and weird things happen and actual noise and motor jitters and stuff. That just absorbs that to make it run smoother and quieter. Now this 18 volt DC motor is going to come from a cordless battery powered electric drill. I bought a DeWalt drill, and then you have the little string that comes off it running through tubing that runs to the muscle. That's what that is. That's actually it. That didn't even take that long. So that's the diagram. It's not even that bad, right? So that's the two types of motorings. Now, one other note is that what I did here with having these 5 MOSFETs and then the 2 diodes and the capacitor is I essentially created my own H-bridge. An H-bridge is a chip you can buy, but I just created my own using all solid-state MOSFETs. You need multiple sets of different batteries because the servo motor takes 6.6 volts. Well, it's supposed to have 6 volts even, but 6.6 is the closest you can get using LiFe batteries, which is lithium iron phosphate. And then, actually, I probably got that wrong. It's lithium. No, maybe it is lithium iron phosphate. I think it is. Okay, and then this other kind of motor this is an 18-volt motor. This is just a 6-volt standard hobbyist servo. This is an 18-volt drill motor. Because the voltage is different, you need to have different control setup. The servo has built-in controls inside it. I have to make these controls external because this is just a motor. It's not a servo. So these are the control mechanisms, and they'll all be controlled by Arduino. Also, the Arduino runs a pin to each of these MOSFETs. I didn't show those here because I don't want more lines coming off. But each one of these MOSFETs will have a line running to the Arduino. I just didn't show that. So yeah, the second set of motors produces 19.6 volts. The first set produces 6.6 volts. So there's two different types of There's two different types of batteries that are needed because you're producing two different types of voltages based upon the different types of motors you're using. The language used on the Arduino is just the standard Arduino language, whatever that is, the sketches. I'll just use Arduino speak when I code the Arduino. But the main AI and brains of the robot are all going to be right here on the main motherboard, main PC running Windows 7 using C++. Arduino is just going to control lower level logic like servo motions and stuff. My main computer will tell it, like, here's where I want you to move the arm. The Arduino will break that down and report back to the main PC through USB, notifying him of his progress and whatnot. So the main PC will always know where the body's at by communicating with the Arduino to ask him, like, what's the latest? Where's the body now? From one battery, different feed lines at different voltages. No, I'm not aware of how to do that, Mogars. I have no idea. Will you protect the motherboard somehow? No. What would I protect? Why would I protect it? You mean physically, like from shaking, or do you mean electrical backflow protection of some sort? There won't be any electrical protection, but it will be mounted inside the rib cage, which will, protect it from damage. I know about voltage regulators, but those just block stuff, right? Like, I don't know how I'd use that in this application. But voltage regulators, which is a potentiometer, they produce a lot of heat, and they just waste power through heat. You're better off to get the right voltage battery. It's more efficient. You're talking about a trimming potentiometer, which I researched as well. I'm probably going to create my own custom battery charging setup that will have the Arduino actually switch batteries, like one pack of batteries. It will switch into charging mode, and then it will toggle on the next set of batteries so that one set can be cooling off or charging, one set can be being used, and they'll take turns. Also, he'll be able to put on a backpack with batteries in it, like a book bag, and he'll be able to switch to those and let all of his onboard batteries recharge while he's using the book bag batteries. And he can bring that with him if he's doing extended period of time where he does not have access to a charger or to a wall outlet. For example, if you were mowing the lawn or competing in some kind of robotic competition where he's not allowed to be tethered to a wall outlet, He would then have extended battery life by strapping on a book bag full of batteries.